All right, so for problem number 10, it says find the intervals for which f is increasing and decreasing. F of x was given as -4 sine of x minus 2x, and it's over 0 to 2 pi. So first thing is, you have to find your critical values, right? So step one, find your critical values. And for your critical values, just remember, that's whenever the first derivative is equal to 0. So for our given function, f, you will need to find its derivative. Well, let's get started on that. The derivative of -4 sine of x is going to be -4 cosine of x. The derivative of -2x is -2. So you take your derivative now, -4 cosine of x minus 2, and set this equal to 0. Well, we're going to add 2 to both sides. So this will give us -4 cosine of x is equal to 2. And then you would divide by -4. So this gives us cosine of x is equal to 2 divided by -4, which, by the way, you can simplify. You can simplify this as half or -1/2. Oh, sorry, -1/2. All right, so in this problem, I did draw 2 reference triangles to try to help us solve this problem. Now, when you think about right triangles and you think about cosine, right, cosine of any angle, when you think about right triangles, is the adjacent over the hypotenuse. So when I look at my 2 right triangles, the one that would make the most sense to use is going to be the 60-degree angle. Why? Because the 60-degree angle has a adjacent side of 1, and we have the hypotenuse of 2. Right? So cosine of 60 degrees, just by looking at this right triangle here, is going to be 1 over 2. But we got to be careful here, because in this problem, if you want to find your critical values, you have to find the critical values in such a way that some angle, when you evaluate it at cosine, it spits out or gives you a -1/2. Now, these angles should have a reference to 60 degrees. If you think about the unit circle now, or just think about angles on the Cartesian plane, it gives you insight on where this where would this cosine of some angle will give you -1/2. So let's say I draw a Cartesian plane here. If I draw the Cartesian plane, and let's say I did draw a circle, just to help us out, we know that when I look at any point on the circle, right, you're going to get an x and y value. The x value is what gives us cosine. So looking at this unit circle here on the Cartesian plane, we're looking for the x values that are negative. X values are negative in quadrants 2 and 3. Quads 2 and quad 3. So if I draw some sort of angle in those quadrants, those angles should have some sort of reference angle of 60 degrees. For example, in quadrant 1, you have your 60-degree angle. In quadrant 2, well, what's 60 plus 60? That's 120. So that will be 120 degrees. But if you think about it, 60 degrees, by the way, is pi over 3. So in quadrant 2, one of our solutions here would be x must be equal to 2 pi over 3. 2 pi over 3 is the same thing as 120. Now, if you look at an angle in quadrant 3 to have a reference angle of 60 degrees, well, it can't be 3 pi over 3 or pi, because if you're at pi, then you're essentially on the x-axis, which is not helpful. So you add another 60 degrees. Well, 180 plus 60 is 240. So a 240-degree angle, well, think about it. How many pi over 3 is that? Well, pi over 3 is 60. 2 pi over 3 is 120. 3 pi over 3 is 180. So 4 pi over 3 is now going to be your second angle. Your 4 pi over 3 is the 240 degrees. Okay, so you can use your triangle, then transfer it to the unit circle. You don't have to memorize the entire unit circle. Okay. All right, so now that we have the two angles, I want to now determine the intervals where the function is increasing and decreasing, so I could set up a table. So step 2 is my table. Oh, sorry. I spelled table wrong. There you go. So you have your intervals. The intervals of interest, we're looking at from 0 to 2 pi. So the first one should be from 0 to 2 pi over 3. The second one should be from 2 pi over 3 to 4 pi over 3. And the last one should be 4 pi over 3 to 2 pi. Right? We're splitting the original interval into now 3 intervals. Now, from each interval, you can choose a test value. In radians, you could use the test values that are basically angles that lies on the axis. For example, if this piece, let's say somewhere here was 2 pi over 3, then from 0 to 2 pi over 3, I can choose this angle, which would be pi over 2. Now, let's say from 2 pi over 3 to 4 pi over 3 is this piece. I could definitely use this angle, which is pi. And then from 4 pi over 3 to 2 pi, if you think about the remaining part now of your circle, I could use something like 3 pi over 2. So for each of your test values, you're plugging them now into the first derivative. So we just want the sign of f prime. Well, let's look back. Our first derivative was defined as -4 cosine of x minus 2. So we actually got to work this out. Well, when x is equal to pi over 2, you're going to get -4 times cosine of pi over 2 minus 2. So what's cosine of pi over 2? Is 0. So -4 times 0 is 0. 0 minus 2 is -2. So you're going to get a number that is less than 0. So since you have less than 0, one of your conclusions is that in the first interval, it is decreasing. All right, let's try it again with pi. What is cosine of pi? -1. Since cosine of pi is -1, -4 times -1 is +4. 4 minus 2 is positive. So it's bigger than 0, so it's increasing. Now, what is cosine of 3 pi over 2? It's 0. So -4 times 0 is 0. 0 minus 2 is less than 0, so it's decreasing. And voila, we are finished. We have the intervals where the function is increasing versus decreasing.